Hello friends, welcome to our channel. Let's have a look at an easy problem, that is today's daily challenge problem, 1800, maximum ascending subarray sum. So we are going to use this video to do some practice and just Hello friends, welcome to our channel. Let's have a look at problem 1800, maximum ascending subarray sum. This is today's daily challenge problem, and the problem logic itself here is rather straightforward. So here I'm going to explain some thought process or demonstrate some coding process. So here we are given a integer array called nums. We want to find the maximum possible sum of an ascending subarray in nums. Notice that we are considering subarrays, so which is contiguous pieces, right? And also ascending means strictly increasing. So if you look at example 1, so the answer corresponding to the last 3 numbers, right? And the second example is very special because the list itself is strictly increasing. The sum is the output. So the last example actually corresponds to 10, 11, 12 for the result, that is 33. And the problem size is bounded above by 100. So in other words, logically it's straightforward, and in terms of problem size it's small. So this problem indeed not hard. So here I'm going to first write a solution using O(n) space. N is the length of the list. So O(n) space first, and then O1 space. As for time complexity, because we need to traverse this list, it's going to be a linear time complexity. So first I'm going to get the length of this nums, and then we notice that for size 1 an element or subarray, so it's always regarded as ascending. So if you consider all the size 1 elements, so then you are going to have the sum to be the number itself. So for this, due to this fact, I'm going to make a copy of this DP table. So the interpretation will be the following. So DPI will be the subarray sum, the ascending subarray sum, maximal the maximal ascending subarray sum ending at index I, right? So this way we just need to return the maximum of this DP table. So we are going to get the result. So for this, let's determine the DP table. So for I in range from 1 to n-1, right? So we are going to compare. So if nums I is greater than nums I-1. So in other words, the current number can be appended to the previous strictly ascending increasing subarray. So the sum ending at here will be DPI will be that of ending at DPI-1 plus nums I. So otherwise it will be just the nums I itself. Due to the way we do the initialization, we don't need to make any changes. So then we just need to return max DP. So this forms a solution format. So we can do a test. It passes all the cases. So now let's move. Because here we are using O(n) space. Let me copy this part and introduce some running variables to make it O1 in space. So I'm going to change this one to be version v1, and here we don't need to use this DP table, and also we just do the max in the process. So first I'm going to get the current will be nums 0, and the result will be nums 0 at the very beginning. So then I'm going to iterate, right? So we are going to get the maximum ascending subarray sum ending at index I. So then we are going to check this one. If nums I is greater than nums I-1, then the current is incremented by nums I. So otherwise, so the current will be just nums I, right? Because the interpretation of current is here. The maximum ascending subarray sum ending at that index. So here we can only start from here. So now we just need to make a comparison, right? So the result will be the pre-state and the current value. So what we want to return is nothing but the result. So this way we change or modified the version we want to be an O1 space solution. Let's do a test. Yeah, it passes the 3 test cases. Now let's submit. Yeah, it passed the generic case. So with that said, I guess that's about it for the current video. Thank you for watching.